So I would like to talk about how AI is disrupting the field of software engineering. AI is generating code that programmers would have written, and that is totally new. This is a whole new paradigm. It's changing the landscape of software engineering. But is it really new? Has something like this happened before? I would like to contend that it has. And if you'll indulge me, I would like to spend a few minutes discussing that with you. So I'm sure some of you already guessed. I'm talking about compilers. And before I go too deep into that, let me just put it out there that I'm not saying they're the same thing. Compilers and AI are not doing exactly the same thing. They're doing very different things, but there's a huge amount of similarity and in what they do, and not just what they do, in the effect that they're having on the discipline of software engineering. And also, I'm not trying to make predictions as to how this whole thing is going to pan out. I'm not qualified to do that. I'm not trying to tell software engineers that these are the skills you can learn now, so your job is more secure. Maybe you'll be able to infer some of that based on this discussion, but I'm not trying to. I don't have a magic wand for you as to predict what will happen 3 years or 5 years down the line. So when we talk about compilers, we want to go back to the 1950s when we had the first few compilers coming out, like Fortran, yes, COBOL, Algol, maybe BASIC was coming out a little later. But what they did was introduce something called the high-level language, and I want to come back to that in a bit, and also talk about natural language processing as we talk about it in AIs. But before these high-level languages came out, what we had was assembly. And assembly was very tedious to program in. With assembly, you had to remember all the registers. You really had to know the processor architecture. You had to do a lot of housekeeping. You had to know what was what in what register, you know the memory locations and whatnot. Uh, when these high-level languages came out, they really took all that housekeeping out. They generated machine code, and machine code is very close to assembly. So when you're programming assembly, you're very close to the machine code. So high level languages just made things so much easier to write programs. So you didn't have to focus on all that housekeeping. You could focus on the real problem at hand. Now, of course, assembly, you could do a lot of optimizations in assembly that you could not do in these high level languages. And there were a lot of things that you could do in assembly that was just not possible in many of these languages. But you also need to know that they opened up the door for new programmers to get into programming. Before that, assembly was like this exclusive club. Programmers in general were an exclusive club. There were not too many of them around. But once we had high level languages, and as more and more high level languages came onto the scene, more and more programmers were able to learn, get trained, and programming became a much more widespread common thing. And even for businesses, it was not something that only the DoD and a few large businesses could hire programmers. Even smaller businesses, relatively smaller businesses, could hire programmers and get applications written that would streamline their business processes. So I want to talk a little bit more about this analogy between the high-level languages and the natural language processing of AIs. The analogy that I see is both are one level up from the previous generation. So with assembly, you were very close to the machine. And with these compiled high level languages, you got a bit closer to the human language, but not that much. It was still a very computer kind of language. And with AI, of course, you're way closer to the human language. You are working in natural human language. So there is an analogy there. The difference is that of scale, of course. Uh, and of course, the effect that it has on the software engineering discipline is very similar. With those high level languages back from the 50s onwards, the number of programmers that could get trained on programming was just exploding. And the same kind of effect is going on now with prompt engineering and building applications using AI. It's reducing the barriers to entry. A large number of people can now get involved in building applications. So the effect is similar. And I think maybe the analogy ends over there because with our current prompts, we don't really have a syntax. With compilers, you had to follow syntax. You made one little error, and the compiler would be like, sorry, can't compile your code. With prompts, you can do what you want. You can use foul language at the AI and it'll still generate code as long as you make it as long as it makes sense. So there's of course that big difference here. So I would like to talk about prompts real quick and also connected with that analogy we discussed about prompts and compiled high-level languages. Now, does that mean since those high-level languages had a strict syntax to be successful, does that mean these prompts also need to have a syntax in the future? Uh, I'm not sure, but I feel not, because the whole point of using natural language AI is not to have that constraint of the syntax. It would really be a barrier to entry for new programmers to get into building applications. So I think the AI is likely capable of handling prompts as long as they make sense. There may be some guidelines. Of course, there are already guidelines on prompting. There may be some stricter guidelines if you really want the code generated to be uh, somewhat predictable. So I see some of that maybe happening, but I'm not sure if we'll get some kind of a syntax like we have with these older legacy high-level languages. The other thing I find very interesting about AI generated code is that it can generate straight to machine language. It can generate an executable. It does not need to generate a high level language code like Python, Rust, or C++. And that's really the end goal, is to run your program. And that can be so much more efficient. You can tell the AI to optimize for speed, or you can tell the AI to optimize for memory or other things, just like with compilers. Now, of course, if you need to interface with a legacy library or something like that, you will need to tell the AI to generate the code in the language where you need to work with, and that's probably going to be a lot of those cases. But as we move on and we start building applications from scratch or building a standalone microservice, a standalone component, we don't need it to be generating a high level language program. We just need the machine code and let it run. Now, of course, you have to specify what kind of system you're going to run it on so that the AI can generate it correctly. And also, if you want to port it from, say, a Windows to a Linux, you'll have to tell the AI to regenerate the code, of course, just like we used to do with compiled languages. We had to recompile it. In this case, the chances of it working are much more. It's going to be really very well portable if all the AIs do it right. So that's something that's going to be really interesting to see how that evolves. So I know I started out saying that I do not want to make any predictions, and I did stray into some minor predictions out there, and maybe there's one more coming. So for that, let's go back to that whole period when these new high-level languages were coming up. I wasn't there, but there must have been a transition period when we went from assembly to starting to use these various high-level languages. I'm sure we didn't lose all our assembly programmers one day all of a sudden. Many of them adapted to these new languages. I'm sure many of them used both. Some stuck to their old assembly programming because there was enough work to do in assembly itself. These new languages were not all that mature. But I'm sure there was work where you needed to know both. You needed to know assembly, you needed to know the new language, and you needed to often integrate with your legacy assembly code. And those skills were very valuable where you had to know both. In fact, I know I learned assembly back in the late 80s as part of my coursework and also did a few fun projects. I was happy to put it on my resume. But once I went into the corporate world, I was programming in C. Uh, I never needed assembly ever again. Uh, though I want to say that having that knowledge of assembly really helped me with my C optimizations. I knew what was going on underneath. I knew what the C compiler kind of knew what the C compiler was doing. I had an idea. So I was not just working at a higher level of abstraction. I knew I could, if I really wanted to, I could drill down into the weeds and do things, even debug in assembly if I really needed to. So I do want to make that point that it was very useful to have that old legacy assembly knowledge while working in a high level language, even back in the 90s. So that's an important point to know. So I think it's fair to say that we are in yet another transition period right now. Just like we had one like 60, 70 years ago, we're having one now where we are transitioning from these high level languages, programming using these high level languages, to building applications using AI. And the lessons we learned from the previous transition should be applicable, most of them, to this transition. And one of the lessons that I can think of is that the skills in both the legacy and the new way of programming are both important. And having both those skills is the killer combination. You need to have the skills of coding in these high level languages, and you need to be very skilled at it. And you also need to know how to program in AI. Just having one or the other is probably not as great as having both. Now, as this transition goes on, and I don't know how long this transition will take, I'm pretty sure that programming in AI will be the way to go. That's really going to be the skill that you're going to need. But for now, I think both are needed. So the other interesting about this older transition from high level, I mean, the assembly to the high level languages, was that there was this big boom in software engineering. New programmers got into the field because it was easier to learn programming on these high level languages. And businesses wanted these engineers because they wanted to build the next set of applications to run their business. They wanted to compete with the other businesses and have the best systems out there. And they fed off of each other. And there was this huge boom in software engineering. I like to think that we'll have a similar boom with our new AI programming. More and more people will start building programs, they'll start building systems using AI, and businesses will want these latest and greatest applications, these latest and greatest systems, because the other businesses have it and they don't want to be left behind. And I'm thinking they will feed off of each other and create another boom in building software. So I would like to wind up on that optimistic note, and let's try and continue this discussion in the comments below, and maybe we'll get to another video. Meanwhile, good luck with everything you're doing, and see you on the next one.